Outer space. The nothing in between the something actually has different classifications. Interplanetary space. This is the space within the confines of a solar system, defined by the solar wind from the sun. But space reaches further. Interstellar space. This is the space in between solar systems, beyond reach of any bubbles of plasma, being under the reign of only the black hole at the center of the galaxy. While that might sound dreadful, there's another terrifying classification of nothing. Intergalactic space. The space in between galaxies. This is what makes up about 90% of the universe, and the interesting thing is this empty space seems to be inconsistent and fluctuant. We can see this in instances like the Boötes Void, or more commonly known as the Great Nothing. A spherical space spanning around 330 million light years in diameter, or 10 septillion, 526 sextillion, 629 quintillion, 999 quadrillion, 999 trillion, 999 billion, 348 million, 310,016 bananas, all lined up. Within the massive volume of the Great Nothing, you could normally expect to see thousands of galaxies, but the Boötes Void only has about 60. To give you a better idea of how empty that really is, we discovered other galaxies, the Andromeda Galaxy, in 1923. But if you were to place our galaxy, the Milky Way, into the middle of the Boötes Void, we wouldn't have even known there were other galaxies in the universe until about the 1960s. So why does this gap in space exist? To answer that question, we must first have a surface understanding of the nature of the universe. The universe is a sponge. Galaxies group into clusters. The Milky Way, for example, is a part of the Virgo cluster. But if you zoom out, you'd see that even clusters form into superclusters. Our Virgo cluster being a part of the Laocoonea supercluster. These superclusters have giant voids of their own, but if we zoom out one more time, we see these massive voids in between superclusters, the biggest being the Boötes Void. Cool, so why does the matter cluster up, forming these huge voids? The short, confusing answer is that we think it's because of various fluctuations just after the Big Bang that have evolved and expanded over 13.8 billion years to leave a much lower density of materials than the areas around it. Blah, blah, blah. Long answer is easier to understand, but a little more complex. Let's go back to the Big Bang. Or more specifically, 10 to the minus 32 seconds after the Big Bang. At this point, the visible universe is quite small. And when I say quite small, I mean incomprehensibly small. At this scale, you'd end up with quantum fluctuations of space-time, which is a lot of words that I barely even know, so let's break it down. Look at the air around you, but zoom in really close to the space in between the atoms. You'll see energy spawning in and out of existence randomly, called quantum fluctuations. But they are so small that they don't really do anything or affect anything. But when the entire observable universe is that small, you best believe that the random spawnings of energy is going to interfere with stuff. You end up with interactions between really simple matter in the universe and light trapped in it being completely confined. These interactions cause oscillations, or in other words, the universe was playing Pong with photons. And the universe continues to play Pong for about 380,000 years when the recombination happens, or basically, the kind of stuff becomes real stuff, the universe forms its first atoms, and because of this, the light is not bouncing around in all that kind of stuff, and is free to expand out indefinitely into the universe. And so is everything else. Hence the ever-expanding universe. And we actually have a picture of that very moment called the cosmic microwave background, or in other words, the fingerprint of the universe. It's a picture of the microwave radiation that fills all of space in the observable universe. Notice how there's random fluctuations in radiation. This is exactly what it was like when things were first let loose and started to expand, which is why everything is clumped up. Because it started that way from random quantum fluctuation, and the space in between is only getting bigger to the unstoppable expansion of the universe. Look on the bright side. There's a really big gap, and that's pretty cool.